Hello everyone, welcome to the solution of another Leetcode problem. So today we are going to solve a problem related to binary trees. So the problem name is binary tree right side view. So it's a very simple problem related to recursion and it can be solved using iterative as well, but we will look at the recursive solution. So without wasting any time, let's go through the problem. Given the root of a binary tree, imagine yourself standing on the right side of it and return the values of the nodes you can see ordered from top to bottom. Okay, so if this is the binary tree 1, 2, 3, 5, and 4, so if a person is standing over on the right side, so whatever values we see from top to bottom, we have to basically return those values. So 1, 3, and 4, right? So this is a very simple problem. So let's take an example of it and see how this can be solved. So we have binary tree 1, 2, 3, 4 over here, 5 over here. Right, so we need to print what is the expected output in this case. uh, 1 is the output, then 3, then 5, as in like if a person is standing over here, what are the values he is going to see. First value is 3, then first value is 1, then 3, and then 5. So this is the output that we need to return. How are we going to do it? So if we observe carefully that uh, at every level we need to output just one value. So suppose this is the level 1, this is the level 2, this is the level 3. So at this level we output this value. At this particular level we have to output just value as 3. We don't need to consider value as 2 here. And at level 3 we need to output 5, right? So it's a just a basic manipulation or the bit change in the in-order traversal. So like how in-order traversal works is like we go to the left node, then we process the root node, then we go to the right side. This is how in-order traversal works. But in our use case, we need to process the root element first, then we go to the right side, and then we process the left side. So suppose our root node is here, we need to process this element. After processing it, before going to the left tree, we need to go to the right tree first, right? And after going to the right tree, we need to process this element first and then further go to the right tree. So at a particular level, we need to maintain whether we have visited that particular level previously or not. So to solve this problem, we will maintain two variables. One variable will be called current level and another variable would be called as maximum level. So current level denotes what level we are currently at. So when we are starting the recursion, so current level would be 1 because we are starting from here, and the max level can be initialized to 0, right? And if at a particular point we see that the value of max level is less than the current level, it means that that particular level has not been visited till now. So we can output the value present at the node itself. So if I write the recursive function over here, so this is the function. Here I am going to pass root, the current level, the max level. That's it. Yeah, just these three values. And if I mention the base condition as well, if root is null, we return it. We don't need to do anything. And as I mentioned earlier that we need to process the root element first, then right, then left. Let me write these two recursion calls first and then I will write the processing of the root element. So if I write over here, what will be the recursion? So I will recursively call this function again with root right, and the level, when I am going to one level below, like from 1 I am going to level 3, node 3, so current level would be incremented by 1, current level plus 1, but the max level variable would remain same. Similarly, after going to the right child, I am going to the left child. Similarly here, current level value would incremented by 1, the max level would remain same. Now how do we process the current element, current node. So when the root is at this node, node 1, I can check if the max level value, if it is less than the current level, it means that that particular level has not been visited. So what we can do is uh, we need to push the value present at that root into our vector that we need to return. So it will be root value. It will be ideally be pushed back. It's okay. And we need to update the max level as well. Max level is equal to current level. That's it. So this is the processing for the current node. If I dry run this code, let us see. So current level initially is initialized to 1, max level is initialized to 0. Right, so current level is 1, max level is 0. And also this max level, it's a we have to pass this value as pass by reference, because this value would be used across all recursion calls. So if suppose one of the recursion calls updates this max value, that value has to be persisted in all the recursion calls. So we need to pass this variable as pass by reference in this function. So we started with this, current level was 1 and max level was 0. So we go inside this if condition. Yeah, this if doesn't seems valid. Now we go inside this if, and we check max level is less than current level or not. So it holds true. So in the vector that we need to return, we push back this one, and max level has to be updated with the current level. So max level would be updated as 1. We can remove this current level because it's not passed by reference. We can just keep a track of max. So max has been updated as 1. Now we go to the first recursion call, root right. So here the current level would be incremented by 1 and the max level would have been incremented to 1. Here also we again check in this if condition if this holds true. So for this also again holds true. So we push back 3 into the vector and max level is updated to the current level. So max value is updated to 2. So this function call is complete. Now we go to this function call. So now we come to 2. So after coming to 2, we go inside this if condition, like the root element is currently this, not this one. Right, so this if condition is not true. Also this if condition doesn't hold true when we are at this node. So when we are at 2, we again call this recursion root right. So we go to 5, and when we went to 2, the value was 2 and 2. And when we go to 5, the current level is incremented by 1 and the max level would remain same, 2. So when we are at 5 and we are doing the processing for element at 5, this if condition is not valid, this if condition holds true, because maximum level currently is 2, current level is 3. So we push back 5 into the vector and max level would be updated to 3. Now 5 doesn't have any left or right child, so this if condition would hold true, it will return. Similarly 5 will return. Now coming back to the left child of 4, here the current level would be 3 and the max level would also have been updated to 3, right? 3 comma 3. So when we are at this node 4, this if condition doesn't hold true. We go to the left and right child of 4, they return null or return nothing. So we came back to 2, so left and right child are already visited, so we return. So processing of 2 has been completed, so 2 returns to 1 and all the complete tree has been visited. So in this way the whole of the processing of the tree is completed and we are left with this vector which has the values as 1, 3 and 5, which are the values of the right view. They are basically the right view of the tree. So here we have nothing done very complex things. Like we have just called the recursion to the right tree first and the left tree first after that. And before these recursion calls, we are checking whether the maximum level that has been visited till now, which we are maintaining in the max L variable, and we are comparing that max L with the current level. What is the current level of that node? And if the current level is greater, which means that level has not been visited as of now. So in that case, we are sure that that is the rightmost node for that particular level. And we push that element into our vector and update our max L variable to the current level. And this max L is passed by reference. So this value will be propagated in all the recursion calls. So that's how we get our rightmost view of the tree. If this problem is somehow changed, like if you want to get the left view of the binary tree, so what will be the changes that we will be doing? There won't be much of the changes apart from just reversing the recursion calls. So here we are going to the right tree first and then the left tree. But if we just visit left tree first and then afterwards right tree, then we would get the left view of the tree. In this case, the left view of the tree is 1, 2, and 4. So through this approach, we are able to solve two of the questions, the left view and the right view of the tree. So I've already written the code for the right view of the tree. So let me walk you through that. So this is the function that we had to write. Here I have created this max level variable, and this current level variable has been initialized to 1, and I'm calling this helper function where I'm passing the root, the current level which is initialized to 1, and the max level which is passed by reference using this ampersand and is initialized to value as 0. This is the base condition. If root is null, then we return directly. And this is the processing of the current node. Right? If the max level is less than the current level, which means this node or this level is not visited yet. And then I'm again calling the right subtree and then the left subtree. So this is for the right view of the binary tree, and if it would have been the left view of the binary tree, so this is the change that needs to be done. That's all. No more change has to be done. Right, so this is the code, and at every point I'm populating this, like if this if condition holds true, I'm populating this vector v, which I've created as a global variable, and finally returning this vector. So if I run this code, yeah, it is accepted. If I submit it, I had previously submitted it as well. Yeah, so runtime and memory usage are perfectly fine in this case. And yeah, so like this was a very simple example of recursion in binary trees, and this is a very example problem which is usually asked in the interviews. So try to understand how the recursion is working by drawing yourself trees. Try to return the values from where the flow is going to where. So that's how you will understand how the recursion is working in this case. So yeah, I will see you next time with another problem of Leetcode. So thank you everyone.